Question 7, Part B. A function f of x is defined by f of x equals 1 plus 2 cos x. Part 1. Show that the graph of y equals f of x cuts the x-axis at x equals 2 pi over 3. X-intercepts represent points where the graph cuts the x-axis. Recall that x-intercepts have a y-coordinate of 0. In other words, where the x-intercepts occur, the value of f of x is equal to 0. Given f of x equals 1 plus 2 times cos x, we want to show that f of 2 pi over 3 equals 0. Substituting 2 pi over 3 for x into the function, we have 1 plus 2 times cos 2 pi over 3, which equals 1 plus 2 times negative 1 over 2, since 2 pi over 3 represents a quadrant 2 angle, and cos of 2 pi over 3 is an exact ratio, and 1 plus 2 times negative 1 over 2 is equal to 0. Therefore, the graph of y equals f of x cuts the x-axis at x equals 2 pi over 3. Part 2. Sketch the graph of y equals f of x for x greater than or equal to negative pi and less than or equal to pi, showing where the graph cuts each of the axes. The graph of y equals f of x is the graph of the base curve y equals cos x that has been dilated or stretched vertically by a factor of 2, and then translated or shifted vertically up by 1 unit. Hence, the graph of y equals 1 plus 2 cos x is a cosine curve with period 2 pi, that's the width of one full cycle, an amplitude of 2, and a line of center y equals 1. Now the minimum value is negative 1 and the maximum value is 3, and we get that by adding and subtracting the amplitude from the line of center. Also note that f of x is an even function. That means it's symmetrical in the y-axis. Here is a sketch of the graph of y equals 1 plus 2 cos x. Note the maximum value of 3 here and the minimum values of negative 1 occurring here and here. Note the points where the graph crosses the x-axis, and because the graph is even, we've shown previously that the graph crosses the x-axis at 2 pi over 3, and because it's an even function, it also crosses the x-axis at x equals negative 2 pi over 3. Part 3. Find the area under the curve y equals f of x between x equals negative pi over 2 and x equals 2 pi over 3. The region in question has been shaded on the graph in part 2. Note that from x equals negative pi over 2 to x equals 2 pi over 3, the region is above the x-axis. So all we need to do to find the area is to integrate 1 plus 2 cos x from x equals negative pi over 2 to x equals 2 pi over 3. Performing the integration, we get x plus 2 sine x from x equals negative pi over 2 to x equals 2 pi over 3. Applying the limits of integration, we get 2 pi over 3 plus 2 sine 2 pi over 3 minus, open bracket, negative pi over 2 plus 2 sine negative pi over 2, close bracket. Now expanding the brackets here and evaluating sine 2 pi over 3, this is an exact ratio, and also sine negative pi over 2, we get 2 pi over 3 plus 2 times root 3 over 2 plus pi over 2, because we have a double negative here, minus 2 times negative 1. And that simplifies to 2 pi over 3 plus root 3 plus pi over 2 plus 2. And that simplifies further. We can collect the like terms here and here, the terms involving pi. And we get 2 plus root 3 plus 7 pi over 6. Therefore, the area is 2 plus root 3 plus 7 pi over 6 square units, which is around 7.397 square units, correct to 3 decimal places.